So this is question number 39 of a heat transfer, and this question is also from chemical engineering exam, and the year of this question is 2011, and the question number is 39, right? So in official question paper you can see this. Now in first now how we are going to proceed in this video. So in first half I am going to solve this question only by giving you the concept of that is related to this solution and the answer. This is the first half of the video, and in second half we are going to see that from where this question has come, and little revision we will do. So if you are only for the solution, to know the solution, you can see the first half of the video and skip the second part. And if you want to revise little bit of heat transfer, then you can keep moving with the video. So first of all, what is the concept here? Let's read the question. Heat is generated uniformly within a solid slab. The slab separates fluid 1 and fluid 2. The heat transfer coefficient between the solid slab and the fluids are H1 and H2. H2 is greater than H1. Here it is written H1 H2 is greater than H1. You have to see, you have to take a point out that respectively, right? So this is important point. The steady state is also important point. Temperature profile T versus X for one dimensional heat transfer is correctly shown by. So this is the graph, and you have to show and you have to tell the answer that which graph is representing the steady state heat transfer in heat generating source, heat generating uniformly. So heat generating source, which graph is showing a steady state heat transfer along with heat generating source in a best possible way, right? So there is two fluid 1 and fluid 2. There is a graph that is given. So for that you had to know the steady state heat transfer equation in generating with a generating heat generating source. A steady state heat transfer with heat generating source, right? So now in this what we are going to study is the equation that we get from here for defining that steady state heat transfer in heat generating source is T is equal to minus AC by K x square by 2 plus C1x plus C2. So this is the basic equation that we get. How we get this equation? By analyzing the heat energy equation of energy transfer, right? So by analyzing, or this equation is generated by equation of energy, right? By balancing heat balance, by doing heat balance, right? So from that after that, this seeing this equation, we can see that this is parabolic in nature. So this is parabolic. If this is parabolic in nature, that means that linear graphs are not possible. So from this or this, any answer is possible, right? So now let's read the second part. Is H2 is greater than H1. H2 is greater than H1 means what this means is, as we know that temperature is inversely proportional to heat transfer coefficient from the Fourier's law, we know, right? So after that, if this is like this, Newton law of cooling, sorry, and if this is the relation, that means that T1 is less than T2. T1 is less than T2, or T1 is greater than T2. If this is if this is H1 is less than, means T1 is greater than, right, T2, right? So if H1 is chota, then T1 is going to be bigger, right now. So this is the result that we are going to get, and from here we can see this eliminate this the right and the wrong answer from wrong option from this question. So the T1. So this is the y-axis. On y-axis, the y-axis represent temperature. That means here the temperature is larger and here the temperature is lesser, right? So this by this relation, this means that T1, that is corresponding to H1, T1 has to be larger than T2, right? So T1, if we are assuming this two temperature and this two temperature, and this is T2 and this is T1 and this is T1 and this is T2, then where the T1 is larger than T2? Here here we can see that here the T1 is larger than T2, right? So from this we can say that this equation, this graph is wrong, and the correct option is A. Okay, so this is the proper description for the correct answer, correct option of this question. Now let's see from where this question has came. So for that we are going to see the mind map of heat transfer. For the mind map of heat transfer, I have made a mind map where first of all what we learn in heat transfer: conduction, where equation of energy we learn, like how we do mass balance. Then after a steady state and unsteady state heat transfer. So from here the concept has come of the steady state heat transfer in heat generating source. So first of all what we study in this topic? First of all we study the basic concept of heat transfer, basic concept of heat transfer, like Fourier's law. Then we know about thermal conductivity. This creates base for the next topic, and that is steady state heat transfer. And in this we study steady state heat transfer in composite wall, steady state heat transfer in composite wall, or we can say composite wall, or we can say, for more generalizing it, constant area, in constant area, a steady state heat transfer in constant area. And second we study in variable area, a steady state heat transfer in variable area. Variable area, what we study? A sphere, a steady state heat transfer in a sphere, and a steady state heat transfer in cylinder, right? Are you getting now? So after that, what we study here, the area is variable. The area for the steady state heat transfer is variable in a sphere and cylinder. And in composite wall, you may have a study. You may have remember this concept. Like this, we draw the graph, and for a sphere and for cylinder, this is the thing that we do. And after that, what we study in after that, the next topic is steady state heat transfer in presence of heat generating source. From this topic the question has arises, and this we study for composite wall, then for sphere, and then for cylinder. So by this you can see that this is the mind map of from the topic where this question has came, and you can see that from this point they have asked the question, so you can get this idea that how you have to study for this topic, right?